All right, so let's take a look at number 12, which asks you to find a polynomial with a leading coefficient of 1 and the given zeros of 3, 2 plus square root of 7. Okay, so in order for me to start this problem, before I start this problem, right, I'm going to apply a theorem. Notice 2 plus root 7 is a 0. By your irrational conjugate theorem, 2 minus the square root of 7 is also a 0. Okay, so you're going to have to write this in. The irrational conjugate theorem, what's in your notes, says that a plus root b is a 0, or vice versa, then a minus root b is a 0. All right, so I'm going to apply that theorem. These guys always come in pairs, where square root of b is an irrational number, which means you can't take the square root of it in your head. Okay, so what we're going to do is go from factor form to standard form, okay? So the first thing I'm going to do is write this in factor form. A sub n, x minus my first 0, x minus my second 0, and then x minus my third 0. I believe they want you to write it in the least degree, right? So notice I kept all these exponents right here with just 1. Okay, so least degree. And over here, they tell us the leading coefficient's of 1, right? So let's substitute 1 over here and then start plugging in our first 0. Our first 0 is 3. Now, when you plug in that second 0 of 2 plus root 7, right, x minus parentheses 2 plus square root of 7, and then brackets, new brackets to start a new bracket, and then x subtract my z3, which would be 2 minus the square root of 7. Okay, so make sure you are very careful with your, in fact, that one looks a little bit, see here, let me just erase this. This should be 2 minus the square root of 7. Okay, much better. All right, so make sure you put parentheses there whenever you're subtracting a quantity of more than one term. All right. Okay, so the rest, right, as I always like to say, is just algebra. Okay, meaning I need to FOIL all this. Now there is a little trick that I'm going to show you in a second here. Let's distribute the minus sign over here. I'm going to get minus 2 minus the square root of 7. If I distribute the minus sign over here, I get minus 2 plus the square root of 7. While you can FOIL a trinomial times a trinomial with these two brackets and then multiply by binomial, you'll get the answer. But a little trick is to recognize that there is a particular pattern over here. And what I'm going to simply do is just put parentheses around here, around my root 7 as well. And if you just study this for a minute, it's like, what is that pattern? I have an x minus 2 over here. I have an x minus 2 over here, right? That's the same term. I have a root 7 over here. I have a root 7 over here. So if you remember your algebra right, this is essentially a minus b times a plus b. And so recall, right, a minus b times a plus b, this is your sum and difference pattern, right, is simply a squared minus b squared. So that's going to help us minimize our algebra. I'm going to use this formula here. It's just a squared minus b squared. So if it's a squared, it's x minus 2 squared, right? This is my a. Subtract b squared, b is root 7. And I'm going to square that. And then that way it'll cut down on your work a little bit more if you recognize that sum and difference pattern. Okay, so the rest is all algebra. We need a FOIL, combine like terms, all that good stuff. You're going to get x squared minus 4x plus 4 minus 7. Combine some like terms. You're going to get x squared minus 4x minus 3. Okay, and then once you reach to this step, right, you're just multiplying a binomial times a trinomial. Okay, so let's finish this problem off over here. I'm going to get x cubed minus x squared. If I distribute this, x cubed minus 4x squared minus 3x. Underneath here, I'm going to distribute the negative 3. Negative 3x squared. Positive 12x. And then over here, plus 9. Okay, so if I add this, I'm going to get my final answer of x cubed minus 7x squared plus 9x plus 9. And there is my polynomial function in standard form. Okay, so that's the idea. Make sure you apply the irrational conjugate theorem, and then make sure you use this little shortcut over here. Okay, a squared minus b squared. Right, a minus b times a plus b, and then the rest is just foiling your binomial and your trinomial. All right, let's move on to number 2. Let's revisit the concept of multiplicity. This time they give you a graph and they want you to write the equation. Now it didn't specify what form, but implied in the problem is going to be factored form. Okay, so let's write the equation of this polynomial in factored form or intercept form. And then the other piece of information is that it's the least degree. All right. Okay, so let's take a look at the graph right here. It looks like it's bouncing, right, at x is equal to -1. This I would call a flex, okay? And then this guy right here I would probably call a cross. All right, so to start us off, I'm going to write f of x is equal to a sub n. So nowhere in this problem does it say the leading coefficient is 1, so you can't assume that it's 1. You just have to write a sub n. And then write x, subtract my first 0, so subtract -1. If it's a bounce and I want least degree, right, I could write 2, 4, 6, 8, 10, 12, 14, etc., right? Even multiplicities are bouncing. But I want the least degree, meaning when I FOIL this, my exponent needs to be the smallest. So I'm just going to use 2. And then over here, my next 0 of 2, x subtract 2, it's a flex, right? Again, I could use 3, 5, 7, 9, 11, because odd multiplicities of 3 or higher are flexing. So I'm just going to use 3 as the smallest exponent. And then last but not least, right, x minus 3, if it's across, the multiplicity is a 1. So there's a good start, right? It's already in factored form, right? But to finish off this problem, right, I need to solve for a sub n. In other words, what is this? And the one piece of information that that you have to observe from the graph is that f of 0, right, the y-intercept is -4. It doesn't have to be the y-intercept. Just look for an exact point on the graph. And so whenever you have a point on the graph, right, you can always plug it back in into your equation and then solve, okay? So over here, when f of x is -4, my x value, right, is just 0. So 0 plus 1. Which is just 1. I'll just show you all the work here. And so this is kind of like your homework where you had to write the equation of a parabola, quadratic function in standard form, right? Plug in the vertex and then plug in the point on the graph. Okay, so solve for a sub n by evaluating. So a sub n times 1 squared, that's just 1. -2 cubed is -8. -3 to the first is just -3. Negative times negative is positive. Oh, okay, sorry. There, I was looking at a typo here. There is a 4 in your actual problem. So let me just change this really quickly. So it crosses actually at 4, right? So let's switch that up here. So this guy right here is also going to be a 4. Okay, so the other 0 was at 4, okay? Again, the multiplicity is still going to be crossing at 4. It's just I wrote 3 instead of 4 for some reason. Okay, so if I multiply this guy by -4, right, I'm going to get positive 32. Okay, so 32, a sub n, -4, a sub n. If I divide both sides by 32, I'm going to get -1/8. All right, so I finally have my leading coefficient. My final answer is -1/8 x plus 1 squared, x minus 2 cubed, right, times x minus 4. And that's all you need to do for writing the equation of a polynomial. Figure out what the multiplicities are at the zeros. Use the least degree, okay, the least exponent of that kind, depending on if it's bouncing, flexing, or crossing. And then if you can find an exact point on the graph, right, plug it in to solve for the leading coefficient a sub n. And there's another example at number 3. You can take a look to see how I did that if you